Alright, so with this video we're going to take a look at some examples. In the last video we saw what sine and cosine and tangent mean. If you haven't watched that video, you should watch these in order. There's an order to them. That's why I numbered them. And so these trig examples we're going to go through from that last video. So we've got this right triangle. No, it's a right triangle because I've marked it with the little 90-degree box. We have triangle dog, or God, or Godot, however you want to pronounce it. You can go in any order. We've got the sides labeled up, 15, 36, and 39. And we have all of our angles there, D, O, and G. I know how big angle O is. I have no idea how big angle D is. It could be a 20-degree angle. It could be a 43-degree angle. It could be a 72-degree angle. I don't know. And we don't care. We're going to learn how to find that later. For now, we don't care how big the angle is. We're going to try and find these ratios. And so I'm going to go through and I'm going to focus on the individual angles so we can see their differences and their similarities. So, we saw yesterday we have 3 trig functions. There's actually 6 total. We only focus on 3 here in this class. In the future, you will see the other 3 and get all 6 trig ratios, and it's just different sides that you're comparing. So if you recall, I'm going to put these down here again, the word down here again that we have to remember the ratios. We have so, ga, toa. If you remember SOHCAHTOA, you will be fine as far as what trig function represents what ratio. You have the SOH, the CAH, and the TOA. S meaning sine, C meaning cosine, T meaning tangent. All of the O's stand for the opposite side, all of the A's stand for the adjacent side, and all of the H's stand for the hypotenuse. The hypotenuse won't change in the triangle no matter what angle I'm looking at. The hypotenuse is what the hypotenuse is. The adjacent side and the opposite side will change depending on what angle I'm focusing in on. So we always got to know what angle we're focusing in on first. But the hypotenuse will never change. The hypotenuse is always opposite the 90 degrees. So regardless of what trig function I'm doing, sine, cosine, tangent, regardless of what angle I'm looking at, D, O, or G, 39 is the length of the hypotenuse guaranteed. So we can get that in there. That's going to stay constant for everything that we do for this example. Now, what is it that we're doing? I notice we don't have anything yet that we're doing. Let me put a little bar in here, and on this side is where we will do all of our examples. We're going to be looking for some things. The first thing that we need to evaluate is the sine of angle D. And so sine, we just abbreviate SIN, and then after it, we have to put something after it. If you just have SIN there, it means nothing. That's just a sin. Get it? But you got to have sine of an angle. There has to be something that represents an angle there. Angle D represents an angle. I could put 45 if I'm talking about the sine of a 45-degree angle, and we will get there in future videos, and we'll see how that works. But here, I'm just looking at angle D. So I have to figure out first what sides I should be looking at. So when I come down here, I'm dealing with sine. So sine is, I don't want to do that. I want the highlighter. So sine is going to be the opposite side compared to the hypotenuse. Well, the hypotenuse is locked. There's no change there no matter what I'm looking at. The hypotenuse is 39. Depending on what angle I'm focusing in on, the opposite side can change. In this problem, because I'm focusing on D, I'll do this all in yellow, because I'm focusing on D, this 36, that's going to be the opposite side, because that is opposite angle D. And that means then that the 15, that is going to be the adjacent side. So all of this stuff that I'm doing in yellow is all because we're focusing on angle D. If I focused on another letter, those will change, and we'll see that as we do some of the other examples that we're going to go through today, or at least in this video. So the sine of angle D, we're going back down to our words, SOHCAHTOA, S stands for sine, O stands for the opposite side. So the opposite side of angle D measures to be 36, and so we put a 36 up here because that is the opposite side of angle D. The hypotenuse is 39, so we put a 39 here, and that is our answer. Now that can be reduced. Those are both divisible by 13, and we should always reduce our fractions, put on the big boy, big girl pants, and reduce every single time. And so if we divide those both by 13, we end up with the actual sine ratio in nice simplified form to be 12 thirteenths. Did I say 13? I meant 3, not 13. Let's get rid of that 1. My bad. Whoop. We'll get rid of it all and re-put it in there. dividing by 3, not by 13. There we go. Now it's reduced correctly. We should reduce, but if you left your answer as 36 over 39, you're correct, but we should always reduce it down to its most simple form, 12/13. We're going to do a couple other examples with this picture. We're going to take a look at the cosine of angle D. We're going to focus only on angle D right now. So for the cosine, if we jump down to our SOHCAHTOA, the CAH, Ka, that stands for cosine, is the ratio of the adjacent side compared to the hypotenuse. We've already got our sides labeled based on D, and so we just have to look at what side is the adjacent side. The adjacent side measures to be 15. The hypotenuse measures to be 39, and so we get 15 over 39, which would be acceptable, but we want to put on the big boy, big girl pants and reduce that, so we're going to divide these. They, again, both divide by 3, not by 13, but by 3, and when we divide them both by 3, we end up with 5 over 13. That's the answer, 5/13. No problem. Finally, we're going to deal with the tangent of angle D. Again, you gotta have an angle in there. You can't just say tan. That means nothing. That's like writing a square root sign without a number underneath. You have to put something there after the trig function. So the tangent of angle D, and that thing that you put after it, just as a reminder, always has to be an angle. I couldn't do the tangent of 15 for this problem. 15 is a side. That doesn't make sense. If I had a 15-degree angle, then I could go tangent of 15 degrees. But I don't see any angle measures outside of the 90, so I can't put any number there based on this picture. Okay, tangent of angle D, if we go back down to SOHCAHTOA, T-O-A, tangent stands for the opposite side divided by the adjacent side. And so when I look at angle D, the side opposite angle D measures 36, the side adjacent to angle D measures 15, and so we get 36/15, and then one more time, we'll put on the big boy, big girl pants and reduce that down. They are, once again, divisible by 3. It's just the way that the numbers that I picked, and so when we reduce that down, we end up with 12 over 5. That's the tangent of angle D. Okay? No problem, right? You're just writing up ratios. There's not a lot of work there to do, right? You look at the picture, you write down the appropriate numbers, and you're done. That's all that it is here in the beginning as we start to learn these ratios. Now, there's other angles in this picture, not just angle D. There's angle O and there's angle G. Now, angle O is a 90-degree angle. We never do trig on 90-degree angles. It just doesn't, it works, and there are ways to work through it, and you'll see that in the future. But for us, we're never going to deal with the 90-degree angle. We'll only deal with the non-90-degree angle ones. So what I want to do is I also want to look at, now that we've got angle D, what about angle G? What's the sine of angle G? We want to find the cosine of angle G, and we want to find the tangent of angle G. Well, if I'm dealing with G, what I got to do is I got to go over to my picture and I got to change my labels. The label of adjacent and opposite aren't necessarily going to be true. Let me just cross those out. The hypotenuse is not going to change. That does not change based on the angles that I look at. The hypotenuse is what it is. But if I'm focusing now on angle G instead of angle D, I'll highlight angle G, then my words change because 15 is not adjacent to G. 15 is actually the opposite side now compared to G. The side that measures 36, that's not opposite of angle G, that's next to angle G. So instead of being opposite, for us now with angle G, that 36 is going to represent the side that is adjacent to G, next to G. Okay? And so our words change based on the angle we're focusing in on. The workload doesn't. So now when I come down to the sine of angle G, the ratio, if we go down to the word, SOHCAHTOA, S-O-H, sine is the opposite side compared to the hypotenuse. If we look at G, we've already got it labeled now. For G, the opposite side of G measures 15. Let's make that look like a 5. Measures 15, and the hypotenuse is 39. And if we reduce that, divide them both by 3, we get the sine of angle G is 5/13. Notice it's different than the sine of angle D. The cosine of angle G. The cosine of angle G is going to be the adjacent side compared to the hypotenuse, so that's going to be 36, which is the side adjacent, divided by 39, the hypotenuse, and that we can divide them both by 3 to get 12/13. Notice the cosine of angle G is different than the cosine of angle D. Finally, the tangent of angle G, that's going to be the side opposite divided by the side adjacent. The side opposite is 15. The side adjacent is 36. So when we reduce that, we get 5/12. Notice that tangent for G is different than the tangent for D. So depending on what angle we have there, it's different. That shouldn't be a surprise. If I did 5 plus 3, that's different than 7 plus 9. No one questions that, but we suddenly throw words in here and things have to be the same. No, they don't. Okay? They can be different. The other thing you do want to notice, though, is the fact that the sine of angle D happens to be the same as the cosine of angle G. Not only that, but the sine of angle G is the same as the cosine of angle D. Well, that's weird. In a triangle, that happens to always be the case. And then finally, the tangent, if you notice, the tangent for angle D is 12/5. The tangent for angle G is 5/12. That's not coincidence either. That's always going to be the case. That only happens in one specific triangle. If we look at one angle and then we look at another angle, there's going to be a lot of similarities there, but notice each individual answer is different. Okay? So this is how we use trig. We just look at the picture and go, okay, based on the numbers that are in the picture, I write down the ratio, what side divided by what side, all depending on what word do I have, sine, cosine, or tangent. On our next video, we're going to look at triangle similarity. We already dealt with triangle similarity once in some previous videos, so if you haven't watched those, you should go back and take a look at triangle similarity, because I'm going to reference some of that stuff. We're also going to look at 45-45-90 and 30-60-90. There are videos on those. If you haven't looked at those, you should look at those, because we're going to be focusing on some of that. And either in the next video or the video following, there will be another homework assignment. So make sure that you follow the videos and work on that homework assignment, and you'll be good to go. But until then, look for the next video and start practicing these sines, cosines, and tangents.